In the early 18th century, Western Europe remained predominantly agrarian, with the majority of the population living in rural communities and subsisting on small-scale agriculture. Britain, while sharing many characteristics with its continental neighbors, experienced structural changes that laid the groundwork for the forthcoming industrial transformation. Population growth, agricultural innovations, and economic expansion collectively created conditions conducive to mechanized production. Agricultural productivity increased significantly due to the adoption of systematic crop rotation methods, improvements in plowing, and selective breeding. Charles Townsend's introduction of the four-field rotation system allowed for a rotation of wheat, barley, turnips, and clover, maintaining soil fertility while reducing fallow periods. This method increased yields and allowed more consistent food production, supporting population growth. Robert Bakewell's systematic breeding of livestock produced larger and healthier animals, providing increased meat, milk, and wool supplies. These innovations led to a surplus of agricultural products, which in turn freed a portion of the rural population from subsistence farming and enabled them to seek employment in non-agricultural occupations. Enclosure laws accelerated these changes by consolidating fragmented strips of farmland into larger, privately owned plots. By the mid-18th century, thousands of common fields were enclosed across England. While this increased productivity and efficiency, it displaced many rural laborers. Displaced families often sought supplementary income through cottage industries, producing textiles, metal goods, and other items from their homes under the putting-out system. Merchants supplied raw materials, such as wool or flax, and collected finished goods, creating a proto-industrial network that connected rural laborers to urban markets without centralized factories. Britain's expanding trade networks supported this emerging economic structure. The growth of the British Empire provided access to a wide range of raw materials, including cotton from India and the American colonies, while offering markets for finished goods. Overseas trade reinforced the integration of agriculture, cottage industry, and early manufacturing. Ports such as Liverpool, Bristol, and London facilitated the import of raw materials and the export of textiles and other manufactured products. Commercial shipping expanded alongside the empire, linking Britain to North America, the Caribbean, Africa, and Asia. Political stability after the Glorious Revolution of 1688 contributed to economic confidence and investment. A constitutional monarchy limited internal conflict and allowed property rights and contracts to be enforced reliably. This environment, combined with an evolving banking system, credit facilities, and early stock companies, encouraged investment in new enterprises. The establishment of patent laws provided legal protection for inventors, fostering a culture of innovation. By 1760, these political, economic, and social factors had created a framework conducive to industrial expansion. Population growth during this period was significant. Britain's population increased from approximately 6 million in 1700 to nearly 8 million by 1760. Improvements in nutrition and agricultural efficiency reduced famine frequency, while gradual advances in public health, including urban water supply and sanitation systems, helped sustain population growth. This growing population provided both labor for emerging industries and markets for goods. Technological knowledge circulated through informal networks, apprenticeships, and the Royal Society. Metallurgy, mechanics, and textile production were subjects of practical experimentation. Artisans, inventors, and entrepreneurs began developing tools and machines that would later be central to mechanized production. Knowledge of water-powered machinery, textile looms, and metalworking techniques spread gradually, preparing the industrial workforce for mechanized operations. In parallel, proto-industrial towns began to emerge. Small towns with concentrations of artisans, merchants, and tradespeople provided the infrastructure for later factory development. These towns, often located near rivers or streams for water power, supported small-scale mills and workshops. The accumulation of technical skill, capital, and labor in these towns provided a foundation for the more centralized production systems that would appear in the latter half of the 18th century. The social structure in rural and urban areas adapted slowly to these changes. Landowners, merchants, and early industrial entrepreneurs accumulated wealth through agriculture, trade, and small-scale industry. Rural laborers increasingly participated in wage labor outside subsistence farming, while the merchant class invested in production and transport networks. These shifts began to create distinct economic classes that would become more pronounced with industrialization: the landowning aristocracy, the emerging bourgeoisie of merchants and industrialists, and the wage-earning labor force. The international context reinforced Britain's emerging industrial advantage. Continental Europe experienced similar agricultural changes, but political instability, fragmented states, and wars limited economic continuity. Britain's colonies supplied raw materials without the same disruptions, providing both stability and resources for production. The British Navy and merchant fleet ensured security and continuity of trade, enabling the uninterrupted accumulation of capital. By 1760, Britain's domestic economy, labor availability, technological experimentation, and colonial networks positioned it uniquely for the onset of large-scale industrial change. Scientific developments also played a role in creating the preconditions for industrialization. Advances in chemistry, mechanics, and engineering improved materials production and machine efficiency. Metallurgists experimented with iron smelting techniques, improving the quality and consistency of metals. Knowledge exchange through scientific societies and publications allowed innovations to spread from one region or industry to another. This integration of scientific knowledge and practical application set the stage for mechanized textile production, steam power, and mass manufacturing. By 1760, Britain entered a period of accelerated technological and economic transformation that marked the formal beginning of the Industrial Revolution. The confluence of mechanized production, energy innovation, and capital accumulation created a distinctive industrial environment. Textile manufacturing emerged as the focal point of innovation, drawing on the skills, resources, and labor networks developed during the pre-industrial period. The textile industry's mechanization addressed a growing demand for cloth, both domestically and internationally. John Kay's flying shuttle, patented in 1733, significantly increased weaving efficiency by allowing a single weaver to operate a wider loom at greater speed. The increased output in weaving created pressure on yarn supply, prompting further innovations in spinning technology. James Hargreaves' spinning jenny, introduced in the 1760s, allowed a single worker to spin multiple threads simultaneously, multiplying yarn production. Richard Arkwright's water frame, patented in 1769, mechanized spinning using water power, enabling continuous operation at scales previously impossible. Samuel Crompton's spinning mule, developed in the late 1770s, combined the mechanical strength of the water frame with the fine yarn quality of the jenny, producing yarns suitable for all classes of textile production. These innovations collectively transformed textile manufacture from a dispersed, home-based system into a coordinated, mechanized process capable of producing large quantities of standardized cloth. The energy base of industrial production shifted toward coal. Coal provided a more reliable and higher energy fuel source than charcoal, allowing the scaling of steam engines and iron smelting operations. Abraham Darby's use of coke in iron smelting during the early 18th century had already demonstrated the potential for large-scale iron production. John Smeaton's improvements to blast furnaces, including more efficient air blast designs, increased the output and quality of iron, providing materials critical for machinery, transport infrastructure, and tools. The development of Thomas Newcomen's atmospheric steam engine in 1712, primarily to pump water from coal mines, addressed the problem of flooding in deep mines. By the 1760s, James Watt's enhancements to steam engines, including the separate condenser and rotary motion adaptation, allowed reliable application in a wide range of industrial contexts, enabling factories, mines, and foundries to operate independent of water sources. Economic conditions encouraged experimentation and investment. Capital accumulated through commerce, land rents, and overseas trade was increasingly reinvested in manufacturing ventures. Entrepreneurs such as Arkwright, Watt, and others operated in an environment where intellectual property protections, patent laws, and financial networks supported the commercialization of invention. The availability of a growing labor force, partly displaced by enclosure and agricultural improvements, provided a pool of workers for industrial operations. Rural laborers, previously engaged in subsistence farming or cottage industries, began transitioning to wage employment, often moving to towns or factory-adjacent settlements. Coal mining expanded rapidly to meet industrial demand. By the 1770s, coal extraction in regions such as Newcastle, the Midlands, and South Wales had increased significantly. Mines required labor-intensive operations to extract coal from deeper seams, reinforcing the integration of industrial work and energy supply. The linkage between coal production, steam power, and iron manufacturing created self-reinforcing industrial growth, as each sector supported and expanded the other. Iron production, using coke-fueled furnaces, supplied materials for steam engines, machinery, and transport infrastructure, further accelerating mechanized manufacturing. Transport infrastructure developments supported the scaling of industrial production. Coastal shipping, rivers, and canals facilitated the movement of raw materials and finished goods. Canals, including early schemes such as the Sankey Canal, opened 1757, enabled bulk transport of coal and iron, connecting mining regions to industrial centers. The integration of transport and production networks allowed manufacturers to source inputs efficiently, distribute outputs to domestic markets, and export goods internationally, linking regional economies into a coherent industrial system. Textile mechanization and energy innovations reshaped labor organization. Early factories concentrated workers and machines under one roof, introducing systematic scheduling, division of labor, and supervision. Workers, including women and children, often performed repetitive tasks under strict time discipline. While wage levels were low compared to emerging capitalist profits, Factories provided consistent employment and access to industrial production, gradually integrating rural laborers into urban industrial economies. This labor transition represented a shift from household-based production to wage dependency, fundamentally altering social and economic relationships. The financial environment reinforced industrial expansion. Banks, private investors, and credit facilities provided capital for the construction of mills, acquisition of machinery, and scaling of operations. Joint stock companies and partnerships facilitated risk-sharing and large-scale investment, allowing entrepreneurs to implement innovations that required substantial initial expenditure. Insurance markets and commercial law further stabilized investment, reducing uncertainty for industrial ventures. These financial structures allowed mechanized production to become profitable at scales beyond individual workshops. Britain's global trade position amplified domestic industrial development. Colonies supplied cotton, flax, and other raw materials critical for textile production. Exports of manufactured textiles, iron products, and other goods provided revenue to reinvest in industrial expansion. Mercantile networks connected ports such as Liverpool, Bristol, and London with markets in North America, India, and the Caribbean. The integration of colonial raw materials into industrial processes underscored the international dimension of Britain's industrial breakthrough, linking domestic technological innovation with global economic structures. Technological diffusion accelerated within and between industries. Knowledge of mechanical spinning, weaving, and power generation spread through apprenticeships, publications, and informal networks. Engineers, mechanics, and inventors collaborated to improve existing machinery and adapt innovations for broader applications. Water-powered mills in Derbyshire, Lancashire, and Yorkshire exemplified the early integration of mechanized textile production with local energy resources, creating industrial clusters that concentrated technical knowledge and skilled labor. These clusters provided a model for later industrial expansion across Britain and, subsequently, continental Europe. In addition to textiles and energy, industrial innovation extended to metallurgy, chemical processes, and machine tools. Ironworks and foundries increasingly produced precision machinery, castings, and tools necessary for industrial expansion. These innovations created interdependent industries. Coal mining supplied energy, ironworks supplied machinery, and textile factories generated demand for both inputs. This systemic integration distinguished the Industrial Revolution from previous episodes of economic growth, establishing a technological and organizational framework capable of sustained expansion. By the end of the 1770s, Britain had moved decisively toward mechanized production. The combination of textile innovation, energy systems, transport infrastructure, capital investment, and skilled labor formed a complex industrial ecosystem. Economic, social, and technological changes reinforced one another, creating conditions for the broader industrial expansion that would dominate the late 18th and 19th centuries. The period between 1760 and 1780 represents a decisive transition. Britain emerged as the world's first industrial nation, establishing patterns of production, labor organization, and technological integration that defined industrial society and set the stage for global influence. By the 1780s, mechanization had transformed textile production into the central pillar of Britain's industrial economy. Innovations in spinning, weaving, and power technology enabled continuous, large-scale manufacturing that displaced traditional cottage industries. Textile factories, concentrated in regions such as Lancashire, Yorkshire, and parts of the Midlands, became the first examples of industrial-scale production. These factories marked a shift from dispersed domestic work to centralized mechanized operations, establishing the factory system that would define industrial society. Water-powered mills were crucial to this transformation. Rivers such as the Derwent in Derbyshire and the Clyde in Scotland provided reliable energy for early mills, which housed mechanized spinning machines and later, power looms. The design of these mills optimized the use of water wheels and transmission systems to drive multiple machines simultaneously. Edmund Cartwright's invention of the power loom in 1785 mechanized weaving, complementing the mechanized spinning established by Arkwright, Hargreaves, and Crompton. The integration of spinning and weaving within the same production system allowed for a continuous flow of materials, increasing output and reducing dependence on skilled manual labor. The demand for raw materials intensified as mechanization increased production capacity. Cotton, largely imported from India and the American South, became the dominant textile fiber, while wool, flax, and linen continued to play a role in domestic and regional markets. The reliance on cotton imports tied industrial production directly to global trade networks and, in the case of the American South, to the institution of slavery. British industrialists benefited from low-cost raw materials, which allowed mills to produce textiles at prices competitive both domestically and internationally. The factory system introduced a new labor regime. Workers operated machines in shifts under close supervision. Time discipline, adherence to production quotas, and strict enforcement of safety and efficiency rules were standard. Women and children made up a substantial portion of the workforce, performing tasks such as spinning, carding, and operating auxiliary machinery. Although wages were low and working conditions often harsh, factory employment provided a steady income and a path into the emerging industrial economy. Labor shortages in some regions led to recruitment from rural areas, further accelerating urban migration. Technological adaptation and innovation were ongoing. The spinning mule, developed by Samuel Crompton in the late 1770s, combined the fine yarn quality of the spinning jenny with the mechanical strength of the water frame, producing high-quality yarns suitable for both domestic and export markets. Continuous improvements in machine design increased efficiency, reduced manual labor, and allowed factories to scale operations. Inventors and millwrights disseminated technical knowledge through apprenticeships, publications, and collaboration among manufacturers, contributing to a regional concentration of technical expertise. Economic structures evolved to support factory-based production. Entrepreneurs reinvested profits into additional mills, machinery, and transport improvements. Credit facilities, banking institutions, and informal investor networks enabled expansion beyond the capacity of individual capitalists. The profitability of textile production encouraged experimentation with mechanization in other sectors, including ironworks, ceramics, and chemical production. This diversification reinforced the interdependent nature of industrial growth. Urbanization was closely linked to the concentration of textile mills. Towns such as Manchester, Blackburn, and Leeds expanded rapidly as workers relocated from rural areas to factory towns. Housing development lagged behind population growth, resulting in dense, often unsanitary living conditions. Public health challenges, including cholera, typhoid, and influenza, became pressing concerns for municipal authorities. In response, local governments gradually implemented sanitation reforms, constructed water supply systems, and improved waste management. The growth of urban centers also fostered markets for consumer goods, services, and leisure activities, further integrating labor and consumption within the industrial economy. The integration of mechanized textiles into global markets had profound economic and political implications. Britain exported finished cloth to Europe, North America, and its colonies, generating significant revenue. Protectionist policies, colonial regulations, and trade monopolies influenced both the supply of raw materials and the markets for finished goods. For example, the British East India Company controlled cotton imports from India, ensuring a steady supply for domestic mills. The interconnection of production, raw material procurement, and global trade reinforced Britain's industrial advantage and facilitated the emergence of a globalized economic network. Industrialization also reshaped social structures. The rise of factory employment created a distinct working class, while factory owners and managers formed an industrial bourgeoisie. Traditional artisanal skills declined as mechanized production replaced individual craftsmanship. In response, labor organizations and early trade unions emerged to represent worker interests. Although these organizations faced legal and social restrictions, they laid the foundation for collective bargaining and labor rights advocacy in the 19th century. The concentration of labor in factories and towns fostered both solidarity among workers and exposure to industrial risks, contributing to social awareness and eventual reform movements. Education and skill development evolved alongside mechanized production. While child labor was common, schools, apprenticeships, and technical instruction increasingly emphasized literacy, numeracy, and vocational skills. Knowledge of mechanical operations, mathematics, and production processes became essential for workforce participation. In some industrial regions, specialized training institutions were established to meet the technical demands of machinery operation, repair, and innovation. This emphasis on education reinforced the long-term sustainability of industrial growth by creating a technically competent labor force. Technological interdependence expanded beyond textiles. Iron, coal, and machine tool production became essential for sustaining mechanized mills. Steam engines, initially applied to pumping water and auxiliary machinery, began to supplement water power in mills located away from rivers. The integration of multiple industrial sectors, textiles, energy, metallurgy, and transport, formed a cohesive system that amplified productivity gains and encouraged further mechanization. The factory system became a template for industrial organization across multiple industries, demonstrating the scalability and adaptability of mechanized production. Labor patterns reflected the social and economic transformation. Women were employed extensively in spinning, weaving, and auxiliary mill tasks, often receiving lower wages than men. Children performed roles such as scavenging, piecing broken threads, and assisting adult operators. Adult men frequently occupied supervisory or machine operating positions, with emerging opportunities for skilled engineering and management roles. These occupational divisions reflected gender norms, technical requirements, and hierarchical organization within industrial settings. By the close of the 18th century, mechanized textile production had created significant changes in Britain's economic, social, and geographic landscape. Factory towns had replaced dispersed cottage industries. Workers were organized into regulated labor systems, and output levels exceeded those possible under pre-industrial methods. The integration of energy sources, machinery, labor, and transport established a framework for expansion into other sectors, setting a model for industrial development that would influence continental Europe, North America, and beyond. The period from 1780 to 1800 represents a consolidation of Britain's industrial identity. Mechanized textiles became the backbone of national production, demonstrating the potential of large-scale factory organization. The combination of technical innovation, labor reorganization, capital investment, and global trade positioned Britain as the world's leading industrial power. The factory system, developed through textile mechanization, provided both the technological and social template for subsequent industrialization in iron, coal, and transport sectors, and ultimately for the broader Second Industrial Revolution in the 19th century. By the 1780s, the convergence of coal, iron, and steam power had initiated a transformative phase in Britain's industrial development, extending mechanization beyond textiles into multiple sectors of production. Steam engines, fueled by coal, enabled factories, mines, and foundries to operate independently of water power, while innovations in iron production provided stronger, more durable materials for machinery, infrastructure, and transport. The integration of these technological and energy systems created a self-reinforcing industrial ecosystem that accelerated productivity and economic growth. James Watt's improvements to the steam engine, patented in 1769, constituted a pivotal development in industrial energy use. By introducing a separate condenser and refining the design for rotary motion, Watt's engine achieved greater fuel efficiency and operational versatility. Steam engines were adapted to drive textile machinery, pump water from mines, and power bellows in ironworks. Factories could now be located away from rivers and streams, allowing industrial activity to expand into coal-rich regions and urban centers. Watt's partnership with Matthew Boulton facilitated the commercialization of these engines, enabling widespread adoption in factories, mines, and later in transport applications. Coal extraction expanded significantly to meet the energy demands of industrial machinery. Mines in South Wales, the Midlands, Yorkshire, and Northumberland increased output to supply both domestic industries and export markets. Mining technology advanced with deeper shafts, improved ventilation, and the use of steam-powered pumps to remove water. The rising availability of coal facilitated a shift in energy consumption from charcoal to coke and coal, a transition that allowed iron production and steam power to scale without ecological or material constraints. Iron production underwent a substantial transformation during this period. Early 18th century pig iron and cast iron were brittle and limited in industrial applications. Henry Court's puddling process, developed in the 1780s, allowed pig iron to be refined into malleable wrought iron. Rolling mills, also introduced by Court, produced standardized iron shapes suitable for construction, machinery, and tools. These innovations increased output, reduced production costs, and enabled the construction of bridges, railways, and steam engines. Industrial centers in the Midlands, South Wales, and parts of northern England emerged as hubs for iron production, leveraging local coal supplies, water sources, and skilled labor. The interdependence of coal, steam, and iron created a technological feedback loop. Coal-powered steam engines increased production efficiency and ironworks and textile mills. Iron, in turn, produced machinery, tools, and structural components for factories and transport infrastructure. This integration extended into transport systems, as rails and locomotives required large quantities of iron, and steam engines enabled the mechanized movement of materials. The combination of energy, material, and mechanical innovation reinforced industrial growth and laid the foundation for large-scale mechanization in other sectors. Technological innovation extended into mechanical engineering. Precision in metalworking and machine tools improved, allowing the manufacture of reliable engines, spinning machines, and mill components. Foundries produced standardized parts, enabling repair, replication, and expansion of industrial machinery. Skilled engineers, millwrights, and mechanics became increasingly important, forming a technical labor layer that supported ongoing innovation and machine maintenance. Apprenticeships and technical training facilitated knowledge transfer, ensuring that mechanized production could be maintained and scaled. The factory system expanded rapidly as a consequence of these technological developments. Concentrating labor and machinery under one roof allowed for continuous operation and greater supervision. Workers operated in shifts, with performance monitored to maintain output levels. Women and children remained prominent in the labor force, performing specialized tasks suited to repetitive machine operation. Adult men increasingly assumed supervisory, technical, and managerial roles. The organization of work within factories represented a departure from household production, imposing discipline, time management, and hierarchical labor structures. Transport infrastructure developed in parallel to support the movement of coal, iron, and manufactured goods. Canals, constructed during the late 18th century, linked industrial regions with ports and urban centers, reducing transportation costs for bulk materials. The Bridgewater Canal, opened 1761, set a model for low-cost canal transport, connecting coal mines to industrial towns. Roads improved through turnpike trusts, allowing faster overland transport of goods. The integration of energy, materials, labor, and transport created a coherent industrial network that increased efficiency, reduced costs, and stimulated further investment. Urbanization was closely associated with the expansion of steam-powered factories and iron production. Towns near coal fields and rivers, including Birmingham, Sheffield, and Glasgow, experienced rapid population growth. Housing construction often lagged behind industrial expansion, resulting in overcrowding and poor sanitation. Despite these challenges, urban centers facilitated the concentration of labor, technical expertise, and commercial activity, reinforcing industrial growth. Local authorities gradually implemented urban planning measures, including water supply, street paving, and waste disposal, addressing the immediate public health challenges posed by rapid industrialization. The global impact of coal, iron, and steam technology became apparent during this period. Britain's mechanized production and energy-intensive industries outpaced continental Europe, which faced political fragmentation, slower technological adoption, and less integrated energy and transport systems. The demand for raw materials, particularly coal and iron, fostered domestic extraction and international trade. The integration of steam engines, ironworks, and industrial transport enabled Britain to export manufactured goods and technologies worldwide, establishing patterns of global industrial leadership. Capital accumulation and financial structures supported the widespread adoption of steam, coal, and iron innovations. Investors, banks, and joint stock companies financed the construction of mills, furnaces, and transport infrastructure. Profits from textile and iron production were reinvested into expanding industrial capacity, creating a cycle of growth that reinforced Britain's technological advantage. Insurance markets and commercial law reduced operational risk, encouraging long-term investment in mechanized production. By the early 19th century, the combination of coal, iron, and steam power had fundamentally reshaped the British economy. Factories operated independently of natural water sources, production expanded across multiple sectors, and urban centers grew in tandem with industrial demand. Energy, materials, and mechanical innovation formed an interdependent system that increased output, reduced costs, and supported further technological development. The period between 1780 and 1820 represents a critical phase in which Britain consolidated its industrial leadership, demonstrating the transformative potential of energy-intensive, mechanized production. The integration of steam, iron, and coal established patterns that would influence industrialization worldwide. Machinery powered by steam and constructed from high-quality iron became central to manufacturing, transport, and mining. Labor organization, urbanization, and capital investment evolved in response to these technologies, setting a precedent for industrial societies in continental Europe, North America, and later Asia. The era marked a shift from regional, water-dependent manufacturing to a mechanized, energy-intensive economy capable of sustained growth, technological innovation, and global influence. The expansion of mechanized production during the late 18th and early 19th centuries created unprecedented demands for efficient transportation networks. Factories required the movement of bulk raw materials, particularly coal and iron, and the distribution of finished goods to domestic and international markets. The transport revolution in Britain was thus both a response to industrial growth and a driver of further economic expansion, integrating regional economies and laying the groundwork for global industrial logistics. Canal construction represented the first phase of large-scale industrial transport infrastructure. Beginning in the mid-18th century, canal networks connected coal fields, ironworks, and industrial towns to major ports and commercial centers. The Bridgewater Canal, opened in 1761 to connect coal mines in Worsley to Manchester, reduced transport costs by up to 50% compared with road haulage. Its success inspired a wave of canal construction across the Midlands, Lancashire, Yorkshire, and the north of England, linking industrial centers and facilitating the low-cost movement of heavy commodities. Canal networks not only transported coal and iron, but also textiles, pottery, and other manufactured goods, enabling factories to expand production while maintaining supply chain efficiency. Parallel improvements in roads complemented canals. Turnpike trusts, established throughout Britain from the mid-18th century, financed road improvements through toll collection. Improved road surfaces, bridges, and maintenance regimes allowed heavier and faster wagons to carry goods overland, connecting rural production centers with urban markets and ports. Road development also facilitated the movement of labor, supporting seasonal migration and the growth of factory towns. The combination of canals and roads created a hybrid transport network capable of meeting the diverse needs of early industrial Britain. Railways marked the second, more transformative phase of the transport revolution. Richard Trevithick's early steam-powered locomotive in 1804 demonstrated the feasibility of using high-pressure steam engines for rail traction, although commercial applications remained limited initially. The Stockton-Darlington Railway, inaugurated in 1825, represented the first significant commercial railway, using steam locomotives to transport coal from inland mines to ports. The Liverpool-Manchester Railway, opened in 1830 under the engineering leadership of George Stephenson, established the viability of railways for passenger and freight transport at scale. The use of locomotives on standard gauge tracks enabled unprecedented speed, volume, and reliability in moving goods and people, revolutionizing internal logistics. The integration of railways and industrial production had immediate economic impacts. Coal and iron could be transported rapidly from mines to factories, reducing production bottlenecks and stabilizing supply chains. Finished textiles, machinery, and consumer goods reached domestic markets more quickly, expanding commercial reach and generating higher profits. Railways also facilitated the growth of ancillary industries, including locomotive and rolling stock manufacturing, rail track production, and engineering services, creating employment and technological specialization. Steamships extended the transport revolution to international markets. Beginning in the early 19th century, paddle-wheel steamships and, later, screw-propelled vessels reduced the reliance on wind-powered shipping. These vessels enabled more predictable and faster transport of raw materials from colonies, such as cotton from India and sugar from the Caribbean, to British ports. Steamships also improved the efficiency of exports, ensuring that manufactured goods could reach overseas markets on schedule. The integration of maritime and domestic transport networks accelerated Britain's industrial and commercial expansion, linking distant economies into a cohesive industrial system. The transport revolution reshaped urban and regional development. Industrial towns grew along canal and railway corridors, reflecting the strategic importance of proximity to raw materials and markets. Cities such as Manchester, Birmingham, Sheffield, and Glasgow expanded rapidly, with populations increasing in response to industrial employment opportunities. Urban planning and infrastructure development lagged behind population growth, leading to overcrowding, sanitation challenges, and environmental pollution. However, the concentration of population along transport corridors facilitated labor availability, commercial interaction, and technical knowledge diffusion, reinforcing industrial productivity. Economic structures evolved in tandem with transport innovations. Entrepreneurs and industrialists invested in canals, turnpikes, and railways, often forming joint stock companies to pool capital and share risk. The profitability of these investments was closely linked to industrial production, creating a symbiotic relationship between manufacturing and transport infrastructure. Financial institutions, including banks and insurance companies, provided mechanisms for investment, credit, and risk management, enabling the sustained development of large-scale transport networks. The social impact of the transport revolution was significant. Railways and improved roads facilitated population mobility, including rural to urban migration and seasonal labor movement. Access to markets expanded consumer choice and lowered prices for manufactured goods, while transport improvements enabled leisure travel, commuting, and cultural exchange. Communication networks, including the telegraph along railway lines, increased coordination across industrial regions, enhancing efficiency in production planning, supply management, and commercial transactions. Technological interdependence characterized the transport revolution. Coal-powered steam engines required iron rails and locomotives, which in turn depended on advanced iron production and metallurgical expertise. Canal construction necessitated hydraulic engineering knowledge, including locks, aqueducts, and reservoirs. The development of transport infrastructure encouraged innovation in mechanical engineering, materials science, and logistics, creating an integrated system of industrial knowledge and capability. The global implications of Britain's transport revolution were substantial. The ability to move raw materials efficiently and distribute manufactured goods rapidly reinforced Britain's position as the world's leading industrial nation. Colonies and trading partners became integrated into Britain's industrial economy, supplying essential resources and consuming industrial output. The transport revolution thus facilitated the global reach of British industrialization, establishing patterns of economic interdependence that would shape trade, labor, and technology flows throughout the 19th century. By the 1840s, Britain's transport networks had created a dense, interconnected industrial system. Canals, railways, improved roads, and steamships enabled the rapid and efficient movement of raw materials, intermediate goods, and finished products. Factories and mines were no longer constrained by geographic proximity to rivers or local resources. Instead, production could be optimized across regions. Urban centers grew in response to labor and commercial demand, while investment in transport infrastructure stimulated complementary industries and technological innovation. The transport revolution, therefore, was not merely an adjunct to industrial growth, but a central mechanism enabling the scale, speed, and reach of industrialization. The period between 1780 and 1840 demonstrates how transport systems transformed economic, social, and technological landscapes. Railways, canals, roads, and steamships interconnected industrial sectors, facilitated labor mobility, and integrated domestic and global markets. This period set the foundation for industrial dominance, establishing transport as a critical determinant of economic efficiency and productivity, and shaping the patterns of industrial society that would persist into the late 19th and early 20th centuries. The rapid expansion of factories and industrial enterprises during the first half of the 19th century fundamentally transformed Britain's urban landscape. Industrialization concentrated labor, capital, and infrastructure in towns and cities, producing unprecedented urban growth. Between 1800 and 1850, Britain's urban population nearly tripled, with cities such as Manchester, Birmingham, Leeds, and Glasgow becoming epicenters of industrial activity. These urban centers embodied the structural changes of industrial society, reflecting both the opportunities and challenges of concentrated mechanized production. Industrial towns emerged primarily in regions rich in coal, iron, and water resources. Proximity to raw materials and energy sources, alongside transport networks such as canals and emerging railways, determined the spatial distribution of factories. Manchester and the surrounding Lancashire region, for instance, became synonymous with textile production, leveraging imported cotton and locally produced machinery. Birmingham and the Midlands developed as hubs of metalworking, engineering, and manufacturing, benefiting from access to coalfields and established transport links. Urban growth was therefore closely tied to industrial geography, shaping the spatial patterns of population and economic activity. The influx of workers into industrial towns created intense demographic pressure. Housing development often lagged behind population growth, leading to overcrowded and substandard living conditions. Terraced housing, built rapidly to accommodate factory laborers, frequently lacked adequate sanitation, ventilation, or clean water. Streets were narrow, poorly maintained, and often unpaved, contributing to the spread of disease. Cholera, typhoid, and influenza epidemics were recurrent problems, highlighting the public health challenges of rapid urbanization. Industrial cities thus became laboratories for urban reform and public health intervention as governments and civic institutions responded to these new social conditions. The factory system imposed a structured regime on labor. Workers, including men, women, and children, adhered to fixed schedules and production targets. Workdays often exceeded 12 hours, with minimal breaks, particularly in textile mills and heavy industries. Child labor was widespread, with children performing tasks such as scavenging, piecing broken threads, and assisting adult operators. Women predominated in textile operations and domestic industries, often earning lower wages than men for similar work. Despite low pay and harsh conditions, factory employment provided a steady income, access to goods, and integration into the industrial economy. Industrial cities exhibited stark social stratification. The industrial bourgeoisie, factory owners, managers, and merchants accumulated wealth, influencing local governance and urban planning. In contrast, the working class faced precarious living conditions and economic vulnerability. Emerging middle-class professionals, including engineers, accountants, and educators, occupied a distinct social tier between the industrial elite and laboring masses. This class structure reflected the economic transformation driven by mechanized production and the concentration of capital, shaping social relations, opportunities, and mobility within industrial towns. Urbanization stimulated auxiliary industries and services. Construction trades, transport services, retail markets, and financial institutions expanded to meet the needs of growing populations and industrial enterprises. Banking, insurance, and credit markets developed to finance industrial expansion, property acquisition, and commercial activity. Public services, including fire brigades, police forces, and sanitation departments, gradually expanded in response to population density and urban hazards. Education, initially limited and uneven, began to formalize, emphasizing literacy, numeracy, and vocational skills to meet the demands of an industrial workforce. Sanitation and public health reforms emerged in response to urban challenges. Municipal authorities initiated measures to improve water supply, remove waste, and control epidemics. The construction of drainage systems, public baths, and medical inspection protocols sought to mitigate the health risks associated with dense urban living. Although these reforms were often incremental and uneven, they reflected the recognition that industrial productivity and social stability depended on addressing the consequences of concentrated labor populations. Transport within cities evolved to support industrial expansion. Horse-drawn omnibuses, improved road surfaces, and later, early rail connections facilitated the movement of workers, goods, and materials. Canals and river navigation complemented overland transport, ensuring efficient distribution of bulk commodities to and from industrial centers. The integration of urban transport with industrial production enabled economies of scale, rapid market access, and expanded employment opportunities, reinforcing the interdependence of urbanization and industrialization. Cultural and social life in industrial cities reflected industrial rhythms. Time discipline became integral, with factory bells, scheduled shifts, and regulated work hours structuring daily life. Literacy and numeracy were increasingly necessary for participation in wage labor and urban commerce. Public institutions, including libraries, schools, and mutual aid societies, emerged to support education, social welfare, and community cohesion. Newspapers, periodicals, and pamphlets disseminated information on industrial innovation, labor conditions, and political developments, fostering civic awareness and informed engagement among urban populations. Labor organizations began to develop as workers responded to industrial conditions. Early trade unions and friendly societies provided mechanisms for collective bargaining, mutual aid, and advocacy. Movements addressing working hours, wages, and workplace safety gained momentum, culminating in legislative reforms such as the Factory Acts of 1833 and subsequent amendments. These measures established minimum standards for child labor, regulated working hours, and imposed requirements for safety and education, marking the state's growing role in industrial labor regulation. The urban revolution also influenced demographic patterns. Migration from rural areas, driven by enclosure, mechanization, and employment opportunities in factories, altered population distribution. Cities became magnets for young adults seeking employment, resulting in gendered labor divisions and household arrangements. Urban households often relied on multiple wage earners, including women and children, reflecting the economic pressures and opportunities of industrial life. Demographic change, in turn, influenced social policy, urban planning, and labor relations, reinforcing the link between population dynamics and industrial development. Technological diffusion was concentrated in urban centers. The proximity of mills, workshops, and engineering firms facilitated the rapid dissemination of innovations in machinery, production techniques, and energy use. Skilled labor, apprenticeships, and technical knowledge accumulated within cities, establishing industrial clusters that supported ongoing innovation. The interaction of technical expertise, capital investment, and labor availability in urban contexts amplified industrial productivity and reinforced regional economic advantages. By 1850, Britain's industrial cities had become fully integrated into the national economy. Urbanization, driven by factories, transport infrastructure, and labor concentration, reshaped social, economic, and physical landscapes. Cities embodied the opportunities, risks, and structural changes of industrial society, providing the spatial and organizational framework for subsequent industrial expansion. The urban revolution demonstrated how mechanized production, labor concentration, and infrastructural development were mutually reinforcing, establishing the patterns of industrial urbanization that would spread to continental Europe and North America. The urban revolution also laid the groundwork for social, political, and economic reform. Public health initiatives, education expansion, labor legislation, and municipal governance evolved in response to urban industrial pressures. The concentration of populations in industrial cities created both the demand for reform and the capacity to implement it. Urban centers became focal points for labor activism, technological innovation, and cultural exchange, illustrating the interdependence of industrialization and urban development. The Industrial Revolution restructured economic and social relationships in Britain, fundamentally altering the interaction between labor, capital, and the state. Mechanized production displaced traditional household economies and artisanal work, replacing independent craft labor with wage labor in factories, mines, and workshops. This transition created a new industrial working class, while consolidating wealth and influence among factory owners, investors, and emerging industrial entrepreneurs, shaping the class structures that define modern industrial society. Wage labor became the central form of employment during the early Industrial Revolution. Factory workers, subjected to regimented schedules, performed repetitive tasks dictated by machinery and production quotas. Adult men, women, and children each assumed specific roles according to physical capacity, skill, and social norms. Women predominated in textile operations and domestic industries, often receiving lower wages than men despite performing essential production tasks. Children were employed extensively, carrying out tasks such as scavenging, operating simple machinery, and assisting adults, exposing them to long working hours and hazardous conditions. These labor arrangements reflected both economic efficiency priorities and social hierarchies within industrial workplaces. Labor unrest and collective action emerged as workers responded to the challenges of industrial employment. The Luddite movement, 1811 to 1816, symbolized early resistance to mechanization, targeting textile machinery perceived as threatening to employment. Workers destroyed machines and organized protests to voice economic grievances. Though the Luddites were suppressed through legislation and military intervention, their actions highlighted tensions between technological innovation and labor security. In parallel, the growth of trade unions and friendly societies provided mechanisms for collective representation, negotiation, and mutual support, laying the foundation for organized labor movements. Intellectual responses to industrialization accompanied social and economic change. Adam Smith's Wealth of Nations, 1776, articulated the principles of free market capitalism, emphasizing productivity, specialization, and the efficient allocation of resources. His framework justified the expansion of industrial enterprise and provided a theoretical foundation for the emergent capitalist economy. Observing the living and working conditions of industrial laborers, Karl Marx and Friedrich Engels developed critical analyses of industrial capitalism, culminating in the Communist Manifesto, 1848. Marx and Engels identified structural inequalities, class conflict, and exploitation inherent in wage labor, influencing subsequent labor movements, political thought, and reform agendas across Europe. The industrial bourgeoisie consolidated economic and political influence during this period. Factory owners, investors, and industrial managers accumulated capital through mechanized production, controlling both production processes and market access. This concentration of economic power allowed industrial elites to shape policy, influence urban planning, and guide infrastructure development, reinforcing the connection between capital accumulation and social authority. The emergence of a new middle class, including professionals, engineers, and merchants, added complexity to social hierarchies, creating intermediaries between industrial laborers and industrial capitalists. Political reform evolved alongside industrial transformation. The British Reform Acts, beginning in 1832, gradually expanded voting rights, reflecting pressures from urban populations and the industrial workforce. Campaigns for political representation, such as the Chartist movement, 1838 to 1857, advocated universal male suffrage, secret ballots, and equitable parliamentary representation, signaling growing political consciousness among industrial laborers. Though many Chartist demands were initially unmet, the movement demonstrated the interconnection of labor organization, social awareness, and political advocacy within industrial society. Economic structures adapted to accommodate the new industrial order. Capital-intensive factories required investment, banking services, and credit mechanisms to finance machinery, infrastructure, and raw material procurement. Joint stock companies, partnerships, and private investment networks emerged to pool resources and mitigate financial risk. Industrialization encouraged reinvestment of profits into expanding production, research, and transport infrastructure, creating a cycle of capital accumulation and technological innovation that reinforced the industrial economy. Social conditions reflected the dual impact of industrialization. While industrial cities offered employment, steady wages, and opportunities for social mobility, they also produced overcrowding, pollution, and health risks. Urban neighborhoods varied in quality, with industrial elites residing in well-planned districts, while laborers often lived in dense, poorly serviced areas. Public health reforms, housing initiatives, and educational programs gradually addressed these conditions, though progress was uneven and often reactive to crises. The juxtaposition of wealth and deprivation in industrial cities highlighted both the opportunities and costs of industrial economic transformation. Labor legislation emerged to regulate working conditions and mitigate exploitation. The Factory Act of 1833 established restrictions on child labor, limited working hours, and mandated basic education for children in factories. Subsequent legislation refined these protections, extending oversight to additional industries and adult workers. The development of labor law reflected the recognition that sustainable industrial growth required balancing productivity with social welfare, contributing to the formalization of the relationship between labor, capital, and the state. Technological innovation and labor organization were interdependent. Mechanized production required skilled operators, maintenance workers, and supervisors, creating a hierarchy of labor specialization. Apprenticeships, technical training, and on-the-job learning ensured that workers could operate, maintain, and improve machinery. Labor knowledge became a critical asset, reinforcing industrial efficiency and supporting the dissemination of innovation within and across regions. The concentration of technical expertise in urban industrial centers contributed to the cumulative development of industrial systems. Industrialization also reshaped household economies and family structures. Wage labor displaced domestic production, altering the economic roles of family members. Women are increasingly engaged in factory and service work, supplementing household income. Children contributed both through labor and education, integrating family strategies into the industrial economy. The temporal structure of family life adjusted to factory schedules, with regular working hours dictating daily routines, meal times, and domestic responsibilities. These changes embedded industrial discipline into social behavior, shaping both economic participation and cultural norms. The interaction of labor, capital, and social reform during this period illustrates the systemic nature of industrial transformation. Economic innovation, technological advancement, and labor reorganization reinforced one another, while social responses, including unionization, political advocacy, and legislation modulated the human impact of mechanized production. Industrial society thus emerged as a complex, interdependent system in which economic productivity, social organization, and political structures co-evolved. By 1850, Britain's industrial economy had solidified its structural foundations. Wage labor, mechanized production, capital accumulation, and urbanization were mutually reinforcing elements of a cohesive industrial system. Social reform and labor organization addressed, in part, the negative consequences of industrialization, establishing precedents for ongoing legislative and institutional intervention. The period between 1780 and 1850 demonstrates the intricate interplay of labor, capital, and social change that defined the first industrial revolution, establishing the organizational, technological, and social patterns that would inform subsequent industrial development in Britain and abroad. Following Britain's lead, industrialization spread across continental Europe and North America, albeit with regional variations influenced by geography, politics, resource availability, and institutional frameworks. While Britain had benefited from early mechanization, abundant coal, iron, and a stable commercial environment, other nations adapted industrial techniques to their unique circumstances, combining domestic innovation with imported technology. Continental and American industrialization demonstrated both imitation and adaptation, producing distinct patterns of economic growth, labor organization, and technological adoption. Belgium was the first continental European country to industrialize extensively, beginning in the 1820s. It possessed rich coal fields in the Sambre-Meuse Valley and a network of navigable rivers and canals, providing the raw materials and transport infrastructure necessary for industrial expansion. Belgian entrepreneurs acquired British technology and expertise, importing machinery for textile mills and ironworks. Cities such as Liège and Ghent became industrial centers, specializing in steel, coal, and textiles. Belgium's state policies supported industrialization through infrastructure investment, tariff protection, and technical education, facilitating rapid growth and establishing a model for industrial development in Europe. France followed a more gradual path, industrializing unevenly across regions. Northern and eastern France developed mechanized textile and metal industries, particularly in Lille, Roubaix, and the Lorraine Iron region, while southern and western regions remained more agrarian. The fragmented political landscape, post-revolutionary economic disruptions, and regional diversity slowed France's industrial adoption relative to Britain. Nevertheless, state-sponsored infrastructure projects, including canal improvements, railways, and road construction, enabled industrial centers to expand. French industrialization emphasized a combination of mechanized factories and artisanal production, reflecting adaptation to local labor skills and market conditions. Germany's industrialization accelerated significantly after political unification in 1871, though early developments occurred in coal and iron-rich regions such as the Ruhr Valley and Saxony. State involvement in infrastructure, banking, and industrial policy supported large-scale industrial enterprises. German chemical and steel industries became particularly innovative, combining scientific research, technical education, and production efficiency. Industrial firms often maintained in-house laboratories, reflecting an integrated approach to technology and production. Urbanization accompanied industrial growth, as cities like Essen, Dortmund, and Cologne expanded to accommodate factory labor technical specialists, and managerial staff. In the United States, industrialization began in New England during the early 19th century. The Lowell system, established in Massachusetts in the 1820s, organized textile production within planned factory communities, employing young women in regimented shifts and providing basic housing and moral supervision. This system reflected a distinctive approach to labor organization and social control, balancing industrial efficiency with domestic labor recruitment. By mid-century, American industrialization extended beyond textiles to iron, machinery, and transportation infrastructure, including canals, railroads, and later telegraph networks. The availability of domestic resources, including coal, iron, timber, and water power, facilitated large-scale industrial development. American industrial growth relied on both mechanization and organizational innovation. Factories integrated mechanized machinery with assembly line principles, increasing efficiency and output. Railroads linked raw materials to factories and markets, enabling regional specialization and national economic integration. By the 1860s, industrial centers such as Pittsburgh, steel, Philadelphia, machinery, and Chicago, meatpacking and transport, had emerged as critical nodes in the national industrial network. Technological innovation, including improvements in steel production, machinery, and steam power, reinforced the United States' capacity to expand industrial output and compete internationally. Industrialization across Europe and America produced varied labor relations and social responses. Continental factories and American mills employed wage labor, child labor, and women workers, reflecting both economic necessity and cultural norms. Trade unions and labor associations emerged in response to long working hours, low wages, and hazardous conditions. In Germany and France, artisan traditions persisted alongside mechanized production, while in the United States, industrial labor was increasingly centralized within corporate-managed factories. Legislative responses, such as labor regulation, education mandates, and social welfare programs, developed gradually to address the human and social impacts of industrial work. Technological transfer played a critical role in continental and American industrialization. British expertise, machinery, and industrial models were often imported directly, accelerating adoption. Engineers, mechanics, and industrial managers migrated to continental Europe and the United States, disseminating technical knowledge. Simultaneously, domestic innovation adapted imported technologies to local materials, energy sources, and labor conditions, producing hybrid systems of industrial organization and production. This dynamic of imitation and adaptation characterized the diffusion of industrialization outside Britain. Transportation networks underpinned continental and American industrial growth. Canals, navigable rivers, and improved roads facilitated the movement of coal, iron, and manufactured goods. The expansion of railways in France, Germany, Belgium, and the United States enhanced connectivity between resource regions, production centers, and urban markets. Rail transport allowed for greater economies of scale, regional specialization, and the integration of national economies, linking industrial output to both domestic and international markets. Financial institutions were integral to industrial expansion. Banks, stock exchanges, and investment networks provided capital for factory construction, machinery acquisition, and transport infrastructure. State involvement, particularly in Germany and Belgium, supported industrial ventures through credit provision, public works investment, and tariff protection. In the United States, private banks and commercial credit facilitated large-scale industrial projects, enabling rapid expansion despite geographic and logistical challenges. Access to finance allowed entrepreneurs to scale production, invest in technological innovation, and coordinate industrial networks across regions. Industrialization reshaped urbanization patterns in Europe and America. Cities near coal fields, waterways, and railways grew rapidly, accommodating factory labor, technical specialists, and commercial personnel. Housing and urban services often lagged behind population growth, creating crowded neighborhoods and public health challenges. Urbanization facilitated the concentration of technical expertise, trade networks, and financial services, reinforcing regional industrial advantages. Cities became focal points of economic, social, and cultural activity, reflecting the integration of industrial production, labor, and urban development. By 1870, Europe and the United States had established industrial economies capable of sustained growth, technological innovation, and global trade. Belgium and Britain were early leaders in coal, iron, and textile production. France and Germany developed diverse industrial sectors, combining mechanization with technical research and artisan traditions. The United States leveraged abundant resources, domestic markets, and organizational innovation to scale production and integrate national transport and commercial networks. Industrialization outside Britain was uneven but increasingly competitive, setting the stage for global economic shifts in the late 19th century. The spread of industrialization had global consequences. European and American industrial centers established patterns of international trade, technological diffusion, and labor organization that influenced emerging economies. Industrial nations exported machinery, investment, and institutional models, shaping the economic development of colonies and non-industrialized regions. The continental and American industrial experience demonstrated both the adaptability of industrial systems and the importance of infrastructure, finance, and labor organization in sustaining mechanized production. Beginning in the 1870s, industrialization entered a new technological and organizational phase known as the Second Industrial Revolution. This period differed from earlier industrialization by emphasizing the integration of scientific research, large-scale corporate organization, and new sources of energy. While Britain had pioneered mechanized textile production, coal-fired steam engines, and early ironworks, the late 19th century saw the expansion of steel, chemical, electrical, and communication industries that redefined the scope and scale of industrial society. The production of steel became central to industrial growth. Innovations such as the Bessemer process, 1856, and the open hearth process allowed for rapid, large-scale production of steel at lower cost and higher quality than traditional wrought iron. Steel's strength, malleability, and versatility transformed infrastructure, transportation, and manufacturing. Railways, bridges, ship hulls, and factory buildings increasingly relied on steel rather than iron, enabling longer spans, heavier loads, and larger industrial complexes. Urban architecture also changed, with steel-frame buildings and factories supporting higher density and mechanized layouts. The chemical industry emerged as a major sector during the Second Industrial Revolution. Germany, in particular, developed expertise in chemical synthesis, producing dyes, fertilizers, explosives, and pharmaceuticals. Industrial laboratories, often linked to universities and private firms, allowed the systematic application of chemical research to production. The combination of scientific investigation, engineering application, and large-scale manufacturing established Germany as a global leader in chemicals and reinforced the model of research-driven industrialization. Electricity became a transformative source of power. The development of electrical generators, dynamos, and transmission systems allowed factories, transport systems, and urban infrastructure to operate more flexibly than with steam alone. Electric lighting extended working hours and improved workplace safety, while electric trams and urban rail systems enhanced transport efficiency in cities. Electrical power also enabled the mechanization of new industries, including metalworking, printing, and telecommunications, integrating energy innovation with industrial production. Communication technologies have advanced rapidly, supporting industrial expansion and economic integration. The telegraph, developed in the 1830s and 1840s, became a global communications system by the late 19th century, facilitating coordination of production, transport, and trade. The telephone, patented in the 1870s, allowed direct, real-time communication between industrial centers, offices, and customers. These innovations reduced transaction costs, improved market responsiveness, and increased the spatial reach of industrial enterprises, linking regional economies into national and international networks. The internal combustion engine and mechanized transport further reshaped industry. Gasoline and diesel-powered engines enabled automobiles, trucks, and ships to operate independently of steam or rail infrastructure. Industrial mobility expanded, creating new logistics possibilities for distribution and production. This phase of industrialization relied on a combination of energy sources, coal, steel, electricity, and petroleum, to sustain diverse and complex manufacturing systems. Industrial organization evolved alongside technological change. The era witnessed the rise of large-scale corporations, trusts, and cartels that centralized production, controlled markets, and coordinated supply chains. Small workshops and family enterprises increasingly merged into corporate structures capable of managing multiple factories, research laboratories, and distribution networks. Corporate capitalism relied on both managerial expertise and technical specialization, integrating administration, finance, and engineering into a cohesive industrial system. Scientific research became integral to industrial competitiveness. Germany and the United States pioneered the establishment of laboratories within firms, linking academic discovery to industrial application. Engineers, chemists, and metallurgists collaborated with production managers to optimize processes, develop new materials, and design machinery. This systematic approach to innovation distinguished the Second Industrial Revolution from earlier incremental mechanization, embedding technical knowledge into the industrial enterprise itself. Transportation and infrastructure continued to expand. Rail networks extended into previously underdeveloped regions, facilitating resource extraction, market integration, and labor mobility. Steamships and increasingly oil-powered vessels accelerated global trade, reducing shipping times and increasing reliability. Urban infrastructure, including electric trams, water supply systems, and sewage networks, was adapted to growing populations and industrial centers, linking social development with industrial capacity. The geographic distribution of industrial power shifted during this period. Britain, while still influential, was surpassed in output by Germany and the United States in steel, chemicals, and machinery. Germany's combination of state coordination, technical education, and research-intensive industries gave it a competitive advantage. The United States leveraged abundant natural resources, domestic markets, and transportation infrastructure to scale production rapidly. Industrial capacity became increasingly concentrated in regions with coal, iron, and petroleum resources, as well as urban centers capable of supporting large labor forces. Labor organization and social structures evolved in response to these changes. Industrial work remained regimented, but unionization, strikes, and collective bargaining became more sophisticated. Worker participation in political life increased, as industrial centers fostered social mobility and civic engagement. Labor reforms gradually addressed working hours, safety, and wages, while education systems expanded technical training to meet the demand for skilled industrial labor. Social dynamics reflected both the challenges and opportunities of a technologically advanced industrial society. Global integration intensified during the Second Industrial Revolution. Industrialized nations exported machinery, chemicals, steel products, and consumer goods while importing raw materials from colonies and trading partners. Patterns of economic dependency emerged, linking resource extraction in Africa, Asia, and Latin America to industrial production in Europe and North America. Industrial technology, corporate organization, and labor practices were disseminated internationally, shaping global economic hierarchies and facilitating the emergence of modern industrial states. By 1914, the Second Industrial Revolution had transformed industry, society, and the global economy. Large-scale steel production, chemical synthesis, electrical power, mechanized transport, and integrated corporate organization defined industrial capabilities. Science and research were embedded in production processes, enabling continuous innovation and efficiency gains. Industrial labor, capital accumulation, and technological application had reached unprecedented levels, creating the structural foundation for 20th century industrial society. The Industrial Revolution reshaped global economic relations by extending industrial power's influence across continents. Industrialization in Britain, continental Europe, and later the United States created unprecedented demand for raw materials, new markets, and investment opportunities, resulting in a reconfiguration of international trade, colonial economies, and labor systems. Industrial powers integrated distant regions into global networks, establishing asymmetrical economic relationships that fundamentally altered production, consumption, and social structures worldwide. Colonial territories supplied raw materials essential to industrial production. India, under British colonial administration, provided cotton, jute, and opium, while African colonies supplied minerals such as copper, gold, and tin, alongside agricultural products like palm oil and rubber. Southeast Asian territories contributed timber, rubber, and spices, feeding European industries. These colonial economies were reoriented toward resource extraction for metropolitan centers, often disrupting traditional agricultural and artisanal production and creating dependence on export-oriented cultivation. The economic integration of colonies into industrial networks reinforced the dominance of industrialized nations in global trade. The impact on local industries was profound. Traditional textile production in India, particularly in Bengal, declined sharply under the influx of cheap British textiles. Handloom weavers, previously engaged in domestic and regional trade, faced loss of income and social disruption. Similar patterns occurred in other colonies, where local crafts were displaced by industrial imports. Industrial powers controlled both the supply of raw materials and the distribution of finished goods, ensuring that colonial economies were structured to serve industrial expansion rather than local development. Railways, ports, and telegraph systems were introduced in colonies to facilitate the movement of raw materials and manufactured goods. These infrastructures enabled efficient resource extraction, linked production regions to ports, and integrated colonies into global industrial networks. While transportation improvements supported local economies in some cases, they primarily served metropolitan industrial interests, accelerating the integration of colonial territories into global production systems dominated by European and North American industrial powers. The global spread of industrialization was uneven. Western Europe and North America led industrial production, technological innovation, and capital accumulation. Asia, Africa, and Latin America experienced selective industrial development, often limited to resource extraction, transport infrastructure, and niche manufacturing serving colonial markets. Japan represented a notable exception. Following the Meiji Restoration of 1868, Japan pursued rapid industrialization, adopting Western technologies and organizational models to develop modern factories, shipyards, steel mills, and rail networks. State-directed industrial policy, technical education, and foreign expertise facilitated Japan's emergence as an industrial power by the early 20th century. Industrialization reshaped global labor systems. Wage labor, formerly concentrated in Europe and North America, expanded to colonial territories through plantations, mines, and factories. Labor migration increased, both voluntarily and coerced, as workers moved to industrial centers, mines, and plantations. In India, Africa, and Southeast Asia, local populations were often recruited into labor-intensive resource extraction and agricultural production, creating global labor networks tied to industrial demand. These systems produced social transformations, including urbanization, altered gender roles, and shifts in family economies. Industrialization influenced global economic patterns and trade hierarchies. Industrial nations exported manufactured goods while importing raw materials, creating trade imbalances that reinforced global inequality. Capital investment flowed from industrial centers to resource-rich regions, enabling infrastructure development, enterprise formation, and market integration, but often under terms favorable to metropolitan powers. Colonial and peripheral economies were systematically structured to support industrialized nations' economic expansion, embedding global dependency relationships that shaped political and economic dynamics for decades. Technological diffusion played a central role in shaping industrial and economic influence. Machinery, engineering techniques, and production methods spread from Britain, Germany, and the United States to colonial and emerging industrial regions. Railways, telegraphs, and steamships facilitated the rapid transfer of knowledge, capital, and labor. Industrial expertise, including factory management and mechanical engineering, migrated internationally, enabling local adaptation of foreign technologies. Industrial powers actively controlled the dissemination of advanced techniques, maintaining a competitive advantage while fostering global integration of industrial processes. The global impact of industrialization extended to military and strategic considerations. Industrial powers were able to project influence through steam-powered navies, modern artillery, and mechanized logistics. Colonial expansion was supported by industrial infrastructure, including railways, ports, and telegraph lines, ensuring both economic extraction and political control. Military-industrial capability became a function of industrial development, linking technological capacity to global influence and shaping the strategies of European and non-European powers alike. Industrialization also influenced social and cultural structures worldwide. Urbanization, wage labor, and industrial consumption patterns introduced new social norms and material expectations. Consumer goods, such as textiles, tools, and processed foods, spread through colonies and trade networks. Education systems increasingly emphasized literacy, numeracy, and technical skills to support industrial economies. Social institutions, including professional associations, public health systems, and municipal governance, were often shaped or restructured in response to industrial and economic imperatives. By the early 20th century, industrialization had transformed the global economic and political landscape. Europe, North America, and Japan dominated industrial production, trade, and technological development. Colonies and non-industrial regions were integrated into industrial networks primarily as sources of raw materials, labor, and markets for manufactured goods. The global economy became increasingly interdependent, yet hierarchically structured, with industrial powers controlling production, distribution, and technological knowledge. Industrialization, therefore, extended beyond national borders, reshaping political authority, economic relationships, and social systems on a planetary scale. Industrialization also influenced environmental patterns on a global scale. Coal, steel, and chemical industries contributed to resource depletion, deforestation, and pollution in both industrial and colonial regions. Urbanization and industrial infrastructure altered landscapes, while transport networks facilitated the movement of materials and people on unprecedented scales. These changes had long-term consequences for agriculture, resource management, and ecological systems, demonstrating that industrial transformation was not only economic and social, but also environmental. The period from 1760 to 1914 illustrates the integration of industrial, colonial, and global processes. Industrial powers harnessed technological innovation, organizational efficiency, and capital accumulation to dominate global trade and production. Colonial territories were reoriented toward resource extraction and export dependence, while emerging industrial nations, such as Japan, selectively adopted industrial models to accelerate development. The Industrial Revolution created both opportunities and inequalities on a global scale, establishing the structures of modern economic, political, and social systems that would persist into the 20th century. Industrialization fundamentally transformed daily life and culture in industrial societies, affecting work, consumption, education, leisure, and social organization. Mechanized production, urbanization, and mass transport reshaped human routines, social roles, and material conditions, embedding the rhythms and requirements of industrial systems into everyday existence. These changes extended across Britain, continental Europe, and North America, influencing both urban and rural populations, while also affecting colonial regions connected to industrial networks. Mass production lowered the cost of goods, increasing availability and diversity for consumers. Textiles, clothing, and household items could be manufactured at scale, standardizing quality and making products more accessible to urban populations. The growth of department stores, shops, and mail-order catalogs provided new mechanisms for distribution and consumption, linking industrial production with domestic life. Consumer access to manufactured goods transformed material culture, enabling ordinary families to acquire tools, furniture, clothing, and utensils that were previously restricted to wealthier households. Transport innovations facilitated changes in mobility and daily routines. Railways, trams, and urban omnibus systems allowed people to commute to factories, offices, and markets, expanding the geographic range of employment and social interaction. Travel became faster, more reliable, and increasingly integrated into everyday schedules, shaping urban settlement patterns and leisure activities. Steamships connected ports and coastal cities, facilitating international trade, migration, and communication. These transport networks tied industrial production to consumption, labor distribution, and cultural exchange. Education systems evolved in response to industrial needs. Literacy, numeracy, and technical skills became essential for participation in industrial economies. Primary and secondary schooling expanded, while vocational and technical institutions trained workers for specialized tasks in factories, railways, and mines. Apprenticeships, trade schools, and university programs in engineering, chemistry, and mechanics created a skilled workforce capable of operating and innovating within complex industrial systems. Education linked social mobility with industrial capability, producing a labor force equipped to sustain technological and organizational development. Urban culture expanded alongside industrialization. Newspapers, periodicals, public libraries, and museums provided information, knowledge, and cultural engagement to increasingly literate populations. Organized sports, public parks, and entertainment venues created opportunities for leisure and social interaction in cities, reflecting both industrial discipline and emerging middle-class values. Urban planning and municipal services responded to population growth, though often lagging behind industrial expansion, producing a complex interplay of opportunity, risk, and adaptation in daily life. Time discipline became a central cultural feature of industrial society. Factory schedules, train timetables, and commercial hours structured daily routines. Punctuality, efficiency, and regularity became not only economic necessities, but also moral and social values, shaping work habits, domestic arrangements, and public behavior. The synchronization of industrial and social time reflected the pervasive influence of mechanized production on human behavior, integrating economic and cultural imperatives into everyday life. Family structures and gender roles were reshaped by industrial labor. Women increasingly participated in wage labor, especially in textile, garment, and service sectors, supplementing household income. Industrial employment often required women to balance work outside the home with domestic responsibilities, altering traditional gender expectations. Children contributed to family economies through employment or domestic labor, while also attending school under emerging education policies. Industrial rhythms redefined household life, embedding external economic schedules into family routines and social organization. Health, sanitation, and public welfare were central concerns in industrial societies. Urbanization produced densely populated neighborhoods with inadequate water, sewage, and waste management systems. Epidemics, respiratory illnesses, and workplace injuries were common, prompting municipal intervention and public health initiatives. Government programs, charitable organizations, and industrial firms increasingly address sanitation, nutrition, and housing, linking social reform with economic productivity. The development of hospitals, clinics, and public health departments reflected the institutionalization of social responsibility within industrial contexts. Communication and information technologies influenced daily life and culture. The telegraph and, later, the telephone connected individuals, businesses, and governments, facilitating rapid communication across cities and continents. Newspapers and periodicals disseminated information on politics, economics, science, and culture, integrating populations into national and global discourses. Literacy and access to printed material allowed urban and rural populations to engage with industrial society's intellectual, commercial, and political dimensions. Work culture itself evolved in tandem with industrial organization. Factory labor introduced repetitive tasks, hierarchical supervision, and standardized production processes. Piecework, time wages, and output quotas shaped performance expectations. Supervisory roles emerged to monitor quality and efficiency, creating a structured division of labor. Workers developed routines that synchronized with machinery, production cycles, and transport schedules. Industrial work embedded mechanical discipline into social and cultural practices, shaping both economic output and human behavior. Industrialization also influenced cultural expression and social norms. Urbanization and mass media facilitated the spread of fashion, design, music, and public entertainment. Education, literacy, and technical knowledge created new avenues for intellectual engagement and professional development. Social norms emphasized efficiency, punctuality, and technical competence, reflecting industrial society's values in personal conduct and public behavior. Cultural institutions adapted to industrial growth, providing organized leisure, education, and civic engagement aligned with urban industrial life. Global industrial networks influenced cultural exchange. Imported goods, technologies, and practices from Britain, continental Europe, and the United States reached colonies and peripheral regions. Urban centers in India, Japan, Africa, and Latin America adopted aspects of industrial culture, including work discipline, education models, and consumer patterns, while simultaneously producing local adaptations. Industrialization thus mediated cultural diffusion, linking local communities to global economic and social systems. By 1914, industrial society had deeply integrated technological, economic, and social transformation into daily life. Mass production, transportation, communication, and urbanization structured human routines, while education, labor practices, and public institutions institutionalized industrial norms. Consumption patterns, leisure activities, and social behavior reflected both the material and cultural consequences of mechanized production. Everyday life was embedded within the rhythms, expectations, and organizational structures of industrial society, demonstrating the pervasive reach of industrial transformation across economic, social, and cultural domains. By 1914, industrialization had reached full maturity in Europe, North America, and Japan, establishing economies powered by coal, steel, oil, and electricity. Industrial capacity, technological innovation, and organizational sophistication shaped both civilian life and military capability, creating systems capable of sustained production on a scale previously unimaginable. The outbreak of the First World War revealed the integration of industrial, economic, and technological development into military strategy, demonstrating the cumulative impact of 150 years of industrial transformation. Industrial production determined military preparedness. Factories, mines, and steelworks were structured to supply the materials, machinery, and munitions required for modern warfare. Steel production, optimized through Bessemer and open hearth methods, provided artillery, ship hulls, rail tracks, and armored vehicles. Coal and oil-fueled transport, mechanized weaponry, and industrial infrastructure, enabling sustained mobilization. Electrical power supported communications, lighting, and production efficiency, reflecting the technical integration of industrial economies. Armaments and machinery reflected industrial capabilities. Artillery, rifles, machine guns, and naval vessels were products of large-scale industrial systems. Factories producing explosives, chemicals, and steel components operated continuously, supported by supply chains that extended from raw material extraction to finished weaponry. Shipyards produced ironclads and later steel battleships, while railways facilitated the rapid deployment of troops and resources. The industrial state had developed a capacity for rapid conversion of civilian production to military use. Mobilization of labor was central to wartime production. Civilian workers, previously engaged in factories, workshops, and transportation, were reorganized to support armament and supply production. Women entered industrial employment in large numbers, filling positions left by men conscripted into military service. Child labor declined as wartime labor demands shifted to adult workers and women. State oversight and corporate coordination ensured efficient labor allocation, integrating industrial organization with national military objectives. The transportation and logistics infrastructure underpinned war efforts. Railways, previously expanded to support commercial and industrial needs, facilitated troop movement, supply distribution, and resource allocation. Steamships and coastal transport systems enabled transnational logistics, connecting industrialized nations with colonies, allies, and global markets. The integration of transport, production, and communication networks exemplified the industrialization of warfare, with industrial capacity directly influencing strategic outcomes. Communication technologies were critical for coordination. Telegraphs, telephones, and signal systems connected headquarters, frontline units, and supply centers. Industrial societies leveraged communication networks developed for commerce and administration to coordinate military operations on continental and global scales. Real-time information exchange enhanced responsiveness, operational efficiency, and strategic planning, illustrating the convergence of industrial and military innovation. The war economy demonstrated the interdependence of industrial sectors. Coal mining, steel production, chemical manufacturing, and energy supply were interconnected, with output in one sector directly supporting others. Centralized management, both governmental and corporate, optimized production schedules, resource allocation, and workforce distribution. The integration of technical expertise, industrial organization, and administrative oversight reflected the maturity of industrial systems and their adaptability to national priorities. Technological innovation accelerated during wartime. Industrial research laboratories focused on explosives, metallurgy, communications, and mechanized transport, producing improved artillery, armored vehicles, and chemical agents. Innovations were rapidly incorporated into production lines, demonstrating the synergy between research, manufacturing, and applied technology. Industrialization provided both the tools and the organizational framework necessary for sustained innovation under wartime conditions. Global industrial networks influenced the distribution of materials, manpower, and capital. Colonies supplied raw materials, including rubber, copper, cotton, and foodstuffs, while industrial nations exported finished armaments, vehicles, and machinery. International finance facilitated resource allocation, industrial coordination, and military procurement. The global integration of industrial economies enabled sustained wartime production, while also exposing the vulnerabilities and dependencies inherent in interconnected systems. The outbreak of war in 1914 revealed the culmination of industrial transformation. Military strength increasingly depended on industrial capacity, technological sophistication, and organizational efficiency. Mechanized warfare, artillery, armored vehicles, machine guns, and chemical weapons reflected industrialized production methods. Transportation networks ensured rapid deployment, while communication systems enabled strategic coordination. The industrial state, combining labor, capital, science, and infrastructure, became the decisive factor in modern military capability. Industrialization had reshaped the political, economic, and social environment. National economies were highly organized, technologically advanced, and globally connected. Urban and industrial labor systems, education, technical expertise, and corporate organization provided the structural foundation for sustained production and adaptation. Industrial powers could mobilize resources, labor, and technology on an unprecedented scale, linking industrial development to geopolitical influence. By 1914, the Industrial Revolution, which began in mid-18th century Britain, had created the structural, technological, and social foundations of the modern industrial world. The transformation encompassed energy systems, production methods, labor organization, technological innovation, infrastructure, and global economic integration. Industrialization had reshaped human environments, economic and political systems, and social structures, producing a world capable of mechanized production, mass consumption, and organized global trade. The outbreak of war highlighted both the power and the vulnerabilities of industrial societies, demonstrating that industrial development was no longer confined to economic growth, but had become central to military capability, international influence, and social organization.